our chemical composition presentation with our same example of nickel-based alloy and see how we can develop confirmation trial by visualizing data in this format, which is what we're going to do exactly when you send us data for reducing 1% rejection rate. Now here, we got these chemistry values for 60 heats, which was the shrinkage defect. But you can start with the 130 values to get an idea. Because what we really found that looking at other case studies is difficult to connect with the foundryman. You're probably more motivated when you see your own responses, which are costing you money, and your own real data. And therefore, then the time that you spend in analyzing it becomes more productive, and then there's motivation to get a confirmation trial and try it on. So what we like to really seek are the existing problems. You don't want to have a problem which was solved 6 months ago. What we like to know is to really demonstrate 1% reduction rate. And also, if possible, that you applied all Six Sigma techniques, and now you want to take one step further. That is where we would like to work at. So it has to be an existing problem with verifiable financial impact onto the company. But the same knowledge which we do in Six Sigma project, we adopt the same problem definition concept. You need to identify the financial impact of doing this exercise and then see whether we achieve that by reducing rejection rate by 1%. So the objective is interpret results and create confirmation trial plan. Again, the same data set. Now I've highlighted these columns because we've just taken this as an example. So along with zirconium and boron, we got aluminium and niobium as well. But then of course we need to analyze, the software will analyze all, or you can develop macros which will analyze all of these factors. And then there is a process again to create penalty values, but that is again a mechanistic process. The purpose today is not to really go into depth of how you generate those penalty values. So let's come back to this, that we input that data, we have those threshold values, we created penalty values, and then we'll get reports like this, the one which we've seen in our previous presentation. Every row in the main effect sheet is an hypothesis. Now what we need to do is to interpret that hypothesis with further evidence on penalty matrix and your domain knowledge, and see whether you want to pick that level into your confirmation trial or not. We will pick up the first line and say that zirconium top 25 is optimal because the strength is 3.5. Anything more than 3, we can take it seriously. If it is more than 3.5, it will be in bold blue color. Zirconium top 50% is 2.1, and there is one interaction here. So we look at the penalty matrix of zirconium. We know its quartiles, the minimum level, maximum level. That's all done automatically. And then we can see this into penalty matrix sheet. And we inspect this penalty matrix for zirconium. And we will see that this is optimal, and therefore we can decide to pick that up for confirmation trial if it satisfies the train in the domain knowledge. This is a point again, you may have to refer to published literature, books, or the trains which are available in public domain. But at the same time, you will also know the number of interactions. You need to keep track of the effect of zirconium on other parameters and other process responses as well. At the moment, we got only one, but the study becomes challenging if you have conflicting responses. That is, one chemistry which minimizes shrinkage defect, maximizes, or at the cost of tensile strength. So one which will optimize shrinkage will change or affect or adversely influence tensile strength. And that's where you want to come up with a common ground. And we'll see that in the second case study, because that thinking is also different from Six Sigma philosophy. As I've said, that we have to also look at interactions, because the main effect could be strong, and if it's very strong, you have to do it anyway. But the main effect is weak, we look at its interactions. In case of interactions, this is our example of boron 50% and zirconium 50%. We made a decision on zirconium to pick it up for confirmation trial, so you can actually put this row into gray background. Just say that, okay, we picked it up. Now, because you decided to keep zirconium in top 50%, you look at all the interactions which zirconium top 50% makes, and also interaction of zirconium bottom 50%. There are 3 interactions which are bad as well. So there is strong evidence to go for top 50% of zirconium. If there is doubt, then you look at the penalty matrix for interactions, because you have a separate sheet of interaction penalty matrices. And when both are occurring, there is a clear evidence, and then it agrees with your domain knowledge or published literature. Therefore, you can pick up boron also in the confirmation trial. So this is how you are picking up different levels for confirmation trial with evidence. And that becomes part of your report to management. And therefore, you are making several changes at the same time by taking into account all the interactions as well as main effect, the optimal interactions as well as avoid interactions. Sometimes there will be conflict. In that case, you will ignore that particular factor. And we'll see that in our second example, which is slightly more complex. The individual strength was low for zirconium and boron, but then the strength of interaction is strong as decided by this. You don't have to just rely on these values. You can actually inspect the particular penalty matrix, because now the whole analysis is driven by penalty matrices. And that evidence is there in the form of sheets, but then it is just written into this format because you can sort this data using Excel functionality or put filters on that data using Excel functionality. The same information of this interaction between zircon and boron is available into interaction sheets. And we've seen the interaction sheet just in the previous presentation. You can look at that zirconium and cobalt and carbon has avoid interaction. So if you make a decision of keeping zirconium in top 50% and boron in bottom 50%, then perhaps you can look at cobalt and carbon and then avoid those ranges as well. And then you end up looking at interactions of carbon and cobalt and see its impact onto other cases. So you start from one, make a decision, freeze one, and then start looking at its root and branch analysis. Look at its different interactions with other parameters, and then make a decision. And once you make a decision, put it into gray because decision is made. That thing goes into confirmation trial. For example, for niobium, strength was very high. Decision on each level by inspecting its penalty matrix for main effect as well as penalty matrix for interaction. Out of those available options, you choose few by checking using your domain knowledge and published literature. Now in this case, for example, we've chosen niobium and aluminium, but then if you want to know that why they are interested, why they reduce shrinkage defect. We just done a typical search, and this is where I've said that we need to refer to peer-reviewed publications, either in the foundry conferences or journals. And incidentally, we just found a typical paper might look like this, where of course this author has done some study in 2009 on the influence of aluminum and niobium on castability of a nickel-based superalloy and published into this journal. If you look at the abstract and the paper, the observation is that if you increase aluminum and niobium, then the result in decreased interdendritic shrinkage porosity, and then they give reasons and justification. If this is a train, now the actual range which they use in that particular experiment could be different. But then you get a train and you get a reasoning for that train. Then you apply this domain knowledge to justify these decisions. But again, this is an hypothesis, and you implement that into your foundry to gain your new knowledge. And that experimentation is then different from design of experiments because you are working onto this tolerance limit. So you're really into tolerance limit design. And this is where we would like to have this indexing. So for example, before your quality control meeting, you have your production data. You found using Pareto analysis that this shrinkage defect is causing us maximum financial loss, and therefore you pick up, not start measuring, you pick up your in-process data which already existed in your foundry across product lines, across time frames. Assuming that you've been calling your process data for last 2 years, you pull out that data, go through penalty matrices, come up with these options, and then come up with a confirmation trial plan before your quality control meeting. With whatever trains, you don't need domain knowledge to come up with this. You just pick up the strong factors which have come out from your in-process data. Then we foresee that you type keywords and such papers should come out. They will say that, okay, these are the 5 or 10 papers which were published into casting journals or Foundry conferences, and therefore they have some insight into those papers. Now, depending on that journal and conference, you either be able to download that paper or get limited access to that particular paper. That gives you sort of a justification of the train. And then you come up with this confirmation trial plan and organize quality control meeting. So you're not just going blank with that these are my rejections, but you're going with all the information which is publicly available and the information which is available within your foundry. Then the production meeting is very cost effective because now you're discussing on options, make a decision that, well, I don't agree with this. I think we need to just focus on these 3 parameters. That's your decision. Implement that into confirmation trial and then move forward. That is where you convert that into a sample confirmation plan. So this is what then should happen into quality control meeting to certify that decision and instruct operators to start tweaking your post-process. You are making several changes at the same time. Now this is just chemistry, but it can go to mole parameters, operator settings, furnace, and you start testing your hypothesis. But it's different from design of experiment philosophy. You cannot do DOE on this, and also the ranges here are quite small because it's a fine-tuning of your process. Now the optimal parameters are a lot easier because it says that niobium should be in middle 50, so you're squeezing your tolerance limit. Carbon in middle 50, further squeeze your tolerance limit. Aluminium, try to aim at the top of the spread. You come up with this plan. The avoid parameters, for example, aluminum plus titanium composition, if you add them together, that should be in the top 75 percentile. So you avoid bottom 25% range because it's got also 3 bad interactions. And when we highlighted that, we would have seen those interactions and made our comments whether to accept or reject. And therefore, this one, you choose top 75% range in your confirmation trial plan. What we foresee that in, say, half an hour of proper brainstorming session, you started from your actual reaction data, but you also come up with options and make decision and then move on. Get feedback, write down your feedback so that suppose next year you've done the analysis again, you can compare this knowledge because you got feedback from your confirmation trial, so it becomes a knowledge, and then compare that with the knowledge next year. Or even use this knowledge for this type of components, and when you get a different component, you not only do a methoding design, but you also set your chemistry for that as a starting point. And that is how you use this previous knowledge in a predictive fashion and start tweaking your process. And that's how you maintain or retain process knowledge. Therefore, what we see that you have to record these results and the feedback from the confirmation trial plan as well.